Awesome. Sorry for this. I just created my presentation last night. But yeah, let's go. So hey everyone, how's it going? So just a quick room check before I get started. How many of you have already heard about rollups? No need to be an expert. Okay, that's good. That's good people. So today I will start with like the basics of what rollups are, and I'm going to discuss a few things. Like for example, there are stacks available out there to like build your own rollups. There are data availability layers. There are a couple of other things like there are ZK rollup, optimistic rollup, native rollups. I'm going to make sure that you understand everything by the end of this presentation. And at the end, if you have any questions, I will be here. And if you have time, we can discuss all those questions. So who am I? I am a senior DevRel engineer at Alchemy. So for those of you who don't know what Alchemy is like a complete on-chain developer platform. We provide rollup as a service, wallets, APIs, RPCs, subgraphs, whatever you need to build your on-chain application. And I completed my research from University de Montreal. I am Ethereum educator. I keep creating content around Ethereum, so you can give me a follow on Twitter. You can check out my content there. Previously, I've worked with companies like Flare, Polygon, and Binance. So here in this space for a while now. So 4 years ago, the Ethereum community took a bold move to this roll-up-centric roadmap, which basically says that we will move to rollups to scale the Ethereum L1. So how these rollups actually work is that it processes the transactions off chain and then aggregates them and bundles them and then submits that bundles to the Ethereum L1. And by this, it inherits the security of the Ethereum L1. So all the major activity happens on these rollups, while Ethereum, which is the L1 blockchain, becomes more robust and settlement layer. So there are different components while building a rollup. So unlike Ethereum L1 or any other L1, rollups actually don't implement everything like settlement, data availability, or consensus. They outsource the management of data availability and consensus to like any other L1. And we will compare different things, and we will also compare data availability layers in the future. But as of now, data availability is like a roll-up transaction, the history of all the roll-up transaction that is submitted to the Ethereum L1. And consensus is basically refers to like the integrity of global transaction. That is like once the transaction are submitted to L1, they can't be changed. So this is what consensus means. So in rollups, one of the important major component is a sequencer. So sequencer is responsible for bundling the transaction and submitting it to the Ethereum L1. So there has been controversies that because most of these rollups as of now have just centralized sequencers, so few people say that it's a bug, few people say it's a feature. And there are networks like Espresso, which are like for decentralized sequencing, so you can even use that. But even though these rollups have centralized sequencer, you can still force exit to the L1 if in case the sequencer is trying to censor you or not trying to push your transaction. So as of now, there are mainly two types of rollups that are available. The one is the optimistic rollups, and the other one is ZK rollup. So optimistic rollups uses fraud proofs, and the ZK rollups uses validity proof. So as the name suggests, optimistic rollup assumes that everything you submit to the Ethereum L1 is kind of correct. But they do have like a 7-day challenge period where if you think that something is wrong, if there is any objection, you can submit a proof. That's where this thing called fraud proofs comes in, which is kind of a proof that is provided by like a verifier, which attempts to run those subset of those transactions again, and then make sure that it validates them. So you can see here that if there is no dispute, then the dispute period ends and the rollup transaction state is finalized. But if there is a proof and there is something wrong, then in this case, like the verifier is like the validator stakes is gone, and it requires like a new state change proposal. And after that, you can even see that if user submits invalid fraud proof, then also that the fault proof is like removed and the dispute period continues. So we have an end of a finalization state. So a few things about this is that most of the time these fraud proofs sometimes are not permissionless, sometimes it is permissionless because there is a thing called delay attack. So what is that? That people, what they can do is they can submit spam proofs. In this way, there is no finalization of the state, right? So that's why it's important that you solve that error. Most of these rollups, I think, initially have solved this and have permissionless fraud proof. But yeah, and then coming back to ZK rollups, with ZK rollups, the thing is like very different because you have this thing called fraud proof. So whenever you submit a state transaction to like these batch of these transactions to the L1, the correctness of that proof is provided by this complex mathematical proof, which is a ZK proofs or a validity proof. So for those of you who don't know how ZK works, is that there is a verifier, there is a prover. The verifier creates a proof, and the prover actually proves that it is correct, right? So it's like, and you don't reveal any of those information. So that's how like the validity proof works in. And with ZK, the problem has been that it has been expensive to use, and it is very hard and expensive to like create these proofs. But as the time passes by, it is becoming more and more easier to like create ZK proofs, and it is becoming low cost. And recently, like Saxon team introduced this real-time Ethereum proving, which is like ability to prove the Ethereum mainnet block in like less than 12 seconds. And Google is planning to use like ZK proofs as well in their identity wallet or something, like to showcase your identity wallet without revealing or showing your ID card, right? So ZK space in overall is growing, but that being said, all the top 5 rollups by TVL as of now are optimistic rollups. So what we might see in the future that things are changing. So this is like an architectural diagram of how any optimistic rollup works right now. This is an example of like OP stack rollup. So as of now, you can see that this is the rollup, and then here is the sequencer, which posts all the transaction that bundles to the Ethereum L1. And then there is a smart contract called L2 output Oracle contract, which actually contains the straight root of the rollup against any withdrawals, and bridging is done, which is like a 7-day withdrawal period. And the correctness of this contract is determined by the fraud proof game that we just saw, like a 7-day challenge period. And when we use ZK rollups, the correctness of this contract is provided by validity proofs, right? And validity proofs, the thing with fraud proof is that you don't need fraud proofs all the time. But with ZK proof, like validity proof is generated for every transaction, every batch that you submit to the Ethereum L1. And there are 4 other components as well that are responsible for other things. An OP proposer is like a thing which submits those transactions to the L1. And this is the blob. So if you're using Ethereum as a data availability layer, you can see here that in the block, there is a specific thing called blobs, which came after EIP 4844. So you have a specific space to submit those transactions to the Ethereum blockchain. So Ethereum is now moving towards and designing themselves to become a more robust settlement layer. So you can see here that there is a space for those rollup transactions to be submitted that is called blobs. So this in general is like how optimistic rollups work in. So what are rollup stack? So rollup stack is more like a chain framework that refers to like set of software components. So think of it like an SDK. Whenever you build an app, you already have those tools and those protocols that work together to like create a function rollups. And the advantages of like using a rollup stack is that there is standardization. So they already provide like set of consistent tools and interfaces, and making it easier for like developers to deploy those applications. And it abstracts away all the complexity. So you don't have to like deal with underlying complexity. You don't have to start from scratch because it's hard to build a blockchain. It's not at all easy. And modularity, like they have modularity frameworks, so you can customize your app. You don't have to use ETH as your gas fee. And the most important thing is like ecosystem support. So whenever you choose one of these rollup stack, you get ecosystem support from them, which is like community support, extensive documentation. Sometimes they also have like monetary benefits as well. And all these stacks are designed with interoperability in mind, which is making it easier to connect with other blockchains. So if you're building your own blockchain and you're not using rollup stack, you have to figure out interoperability. You have to start from scratch. So it's hard to build like basics from the scratch. Even blockchains like Sonium, which is like a blockchain of rollup of Sony, they also used even OP Stack to build it. So I built this comparison chart to compare these two stacks, which is like OP Stack and Arbitrum Orbit. These are the two famous stacks out there, and most of them, both of them are for optimistic rollups for building those. So in OP Stack, it's like they have MIT license, and then Arbitrum Orbit has business source license. And the priority ordering, what does it mean? Is basically ordering means how your transactions are ordered when you submit it to the blockchain. So OP Stack has this thing called priority fee, which is basically saying that if I give you this priority fee, make sure that my transaction is on top of the block. So this is like a priority ordering, but in Arbitrum Orbit, they have first come, first some ordering is that whenever you submit a transaction, so whoever serves the transaction first, submits the transaction first, it is going to order in that way. They do have like time boost, which is similar to priority ordering. And then OP Stack default time is 2 seconds, but with flash blocks, which is like an extension, just like MEV boost, you can cut it down to 200 milliseconds, and then default time is in Arbitrum Orbit is 250 milliseconds. And then as we discussed, OP Stack has super chain interoperability, and then Arbitrum Orbit has universal intent engine. With OP Stack, you can't use your personal token as a gas fee. You have to use ETH. But with Arbitrum Orbit, you have that feature that you can use your own token as a gas fee, providing utility to your token. And both of these supports like forced L1 inclusion support. So even the sequencer is like trying to censor you, you can exit via forced L1 inclusion. And these are a few chains that uses these rollup framework. So now what is a DA layer, which is another component of the rollup ecosystem? It basically refers to that all the transaction data that you submit to the L1 is available. So it is important because it allows nodes to like independently verify those transactions without trusting any other entity. And the rollups transaction data is submitted to these DA layer, which is available basically for anyone. In some of the cases, this data availability layer can be another blockchain, but in some of the cases, it can be just a network. So what are the data availability layers that are available right now in the market? So, and this is all like, I'm not biased towards anyone because I don't work anywhere, so I'm just giving you proper information. And Celestia is like L1 blockchain, as we discussed, like Celestia, Avail, and Ethereum is a specific L1 blockchain, while EigenDA is kind of a DA service, like a network. And important thing here is that you can check out the block time and the time to finality of these block and DA sampling, and then data throughput, how much data throughput it is giving each second. So TLDR here is that if you want like if you are looking for like security concerns, and if you want like a secure data availability layer, then you always choose like Ethereum, because Ethereum has been here for a long time. It is like the most secure. But if you're looking for something with more flexibility, you want like faster finality, so you can use like any other DA layer like Celestia, EigenDA, and Avail, and then you can compare what are the chains available. And then you can see that Eclipse using Celestia, EigenDA is used by like Mega E. This is one of the rollup that is coming out faster. And then Ethereum is like all the major rollups, which is Base and Optimism and Arbitrum Coin, Arbitrum and Worldchain uses Ethereum. There is a quick difference, by the way, we will discuss in the future, that if you use another DA layer other than Ethereum, then you are called as Validium and OPM, so you're not really a rollup. There are rollup stages that we can discuss. So stage 0 is basically on a full training vs. That means that if your rollup is in stage 0, it is effectively run by the operator, but still there is like a source available software that allows you to like reconstruction of this state. So there is still transparency and verification. And stage 1 is like limited security, which is like enhanced rollup government. So the rollup is governed by a smart contract, and there is a security council that is in place for like bug resolution. But there is like a fully functional proof system with like a decentralized fraud proof, so anybody can submit those fraud proofs and validity proofs that we just saw. And the stage 2 is like no training wheels at all, which is like fully decentralized, and a smart contract like fully manages the rollup. And at this point, like all the fraud proofs, all the validity proofs are like permissionless, so anybody can submit those proofs. And there is still a security council placed, but it is in case of like extreme governance attacks or anything like that. So we only have like 15 minutes and 10 minutes left. So I just want to make sure that I give you I shout out all the terminologies that are available right now. So based rollups is kind of like a new concept that is by Justin Drake, a researcher at Ethereum Foundation. So it is a network where like the base layer, which is the L1, which is the Ethereum, is in charge of the sequencing of the transaction. Sequencing what we just saw, how do you sequence your transaction? So as of now, like there was a single sequencer who was doing that in all these rollups, but with based rollups, it is done by Ethereum L1. So searchers, builders, and proposers, all that PBS, proposer builder separation game that exists on like the Ethereum network, that is going to perform the sequencing. So in this way, like that centralized sequencer problem is going to be solved. And then another one is like native rollups, and native rollups by contrast are built to be like executed and validated natively by Ethereum itself. So instead of relying on like external verification, native rollups use like an execute precompile that allows Ethereum's core protocol to like re-execute and verify the transaction of these rollups. And as of now, like there is no native rollup, and there is one based rollups, I think Taiko, yeah, as far as I know. And then another one is ultrasound rollup. So ultrasound rollup is like when you combine the based rollup and native rollup, then you get like ultrasound rollup. And ZK rollups, we just discussed that uses ZK piece or like fraud proofs, validity proofs as their proof system. And then optimistic rollup utilizes like fraud proofs as their proof system. And then you have Validium. So this is what I discussed. If you used external DA layer and if you use ZK proofs, then you are known as Validium. If you use external DA, which is not Ethereum, and uses optimistic proof, then you are known as Optimium. And stage 2 rollups, again, is like the end goal where there is permissionless fraud proof. Anybody can submit those fraud proofs and minimal oversight, like only a security council is placed. And then there are different layers: data availability, execution, settlement, and consensus. So I hope you guys know now what to do when you want to launch your own rollup. You have to choose all these things: data availability layer, what framework do you want to choose, and what kind of modularity you want. And why run a rollup? So launching your own rollup provides cost efficiency and increased scalability and customization, because you can customize yourself, and you are actually leveraging like ETH security and making it cheaper for your users. So it is more faster and reliable. As you can see, like World has 50% of OP mainnet transaction, which makes sense for them to like have another layer and have more efficiency and cost effective for your users. And then customization and then financial incentives for sure. So whenever you run a rollup, you get this sequencer fee and MEV, and like if you use native guest token, you also have like people are using your token, so it has a utility. So there are a couple of financial benefits, and we have seen like things like Sony has launched their own rollup, and then Coinbase launched Base. So people are moving towards like launching their own rollup. And why go with a rollup provider? So RAS platform is like a rollup as a service, which allows any team to like run their own chain regardless of their technical expertise at low upfront cost. So why RAS? So if you want to like launch a rollup, you need a full infra engineering team to like maintain that chain like 100% of the time. And this also makes sure that your chain is secure. And also in-house costs are always higher. So you don't need to worry about ongoing maintenance. You can have another team who can manage your rollups, while you can focus on like providing better UX to your users. And you can also make sure that you are focusing on like application builders, so you attract those builders, right? You don't have to worry about the infra, right? And there is time and cost savings for sure, and customization and modularity. So whenever you choose a RAS provider, they have this customizations, and they provide block explorer support from day one, validator tools, API indexer, or wallet services. So whenever you're building a chain, you need these wallet services, right? Account abstraction. So it is provided from day one, so you don't have to worry about all that, right? And why rollups really choose Alchemy? So we power like bigger apps like Polymarket and OpenSea, which are like the most used on-chain apps out there. And on day one, we support different stacks like data availability layer. We have extensions like rollup-boost. We have OP succinct. OP succinct is kind of a thing where you convert like any optimistic rollups to a ZK rollups, and it's very important to like choose a provider who is like reliable. Why? Because there have been incidents in the past where a rollup has gone down because something happened with the particular rice provider, and recently also there was NFT API platform that got shut down, and it created like a chaos among the developer community. So they ran away and they wanted another solution for that. So you don't want to choose a RAS provider that could go down, or it could go bankrupt in like few years, because you are here for the long-term game. So it's very, very important to like choose a right provider. And we have like best-in-class data tools and APIs. We have like wallet services, account abstraction support, and you can choose the interop that fits your rollup best. And yeah, so everything you need for your rollup is with Alchemy. So I think, yeah, that's it. Thank you for joining. We do have our grants program for like rollups deploying on Arbitrum Orbit. So you can scan here. So if you're planning to build a rollup with Arbitrum Orbit, you can apply to that. And then for apps and rollups who are building using wallet services, they can also apply here. And yeah, give me a message, drop me a message on Twitter. I'm pretty much active there. And I think we have time for questions. So if any of you have any questions, happy to take it.
Yeah, thanks a lot, Uttam. And we have a few minutes for the question.
Here. Here. I'm sorry. Thank you. What about app chains? Like, do you need to create a rollup to create an app chain, or is a separate thing?
Yeah, you can customize your app chains too. Like, we do support app chains as well. So if you want, even for app chains, you can use like an external data availability layer. You don't have to like choose specific data like Ethereum itself. You can use Celestia or anything else. So you can have customization as well for your app chain as well. Yeah. Cool. I think that's it.
Anyone else having a question? You have the time as of now.
Awesome then. Thank you so much.